Welcome everyone. I am Dave Gilbert. I'm a very big 3D printing enthusiast. First, I'm going to ask all you guys, who has some experience with 3D printing? Okay, 2 people. Okay, who thinks it's pretty cool? Okay, okay. So, first things first, this is my 3D printer. I made it myself. This is a design that I will post up later on this slideshow. And we'll talk about other stuff too. But first, what is 3D printing? The obvious first slide. And 3D printing over the years has had multiple different names associated with it. Additive manufacturing, because 3D printers were the only method to make something by adding onto it as opposed to subtracting from it. Sculpting, milling, all those things subtract from the source material. 3D printing is an additive. It builds up. It's also referred to as prototyping. When it was first created in the mid to late 80s, that was what it was primarily used for. Getting a design quickly out the door and being able to test it before shipping out to China to be manufactured locally. So those are 2 names. Those are what it is. Essentially, what is 3D printing is you're making stuff. And we all like making stuff, right? Okay. So how does it work? There's a common technique between all of them is building up layer by layer by layer. There are multiple ways to do this. One's called selective laser sintering. The other one's called stereolithography. The other one's fused deposition modeling. Fused deposition modeling is the one we'll be focusing on tonight. FDM for short, and some people call it fused filament fabrication, just to make it a little bit more.
First things first, selective laser sintering is the high end of the 3D printing model space. It uses a laser to fuse together tiny particles of materials, layer by layer, to build up a very fine, detailed model. You might have seen models like these come from places like Shapeways and Pinocchio. They all do a selective laser sintering process, and this allows them to have a very wide range of material use in their setup. There are some pros and cons to it. They have a wide material choice, a very high resolution, but it is quite expensive. It is the printers themselves run in the range of 20,000 and up, and the material comes from very small, very niche marketplaces that overcharge greatly. And of course, there's also a health and safety concern with working with tiny particles of material. You want to make sure you're wearing a proper respirator and make sure it gets clean before it goes off to the end user. And otherwise, we all know lung issues with that. Stereolithography is one of the methods for using a resin to make a 3D print. Stereolithography is also colloquially can be referred to as DLP, digital light projection, and both of these use resins to build up layer by layer or build down layer by layer, depending on how the print bed surfaces or lowers to match the laser input. Yes, in the stereolithography method, it uses a single beam of laser, and it redirects the light with an XY mirror. You can see right there, up there. And that creates a full 3-dimensional drawing because you have the X stage that dips down into the liquid. This is my personal favorite type of 3D printing because it just looks the coolest. Because once you get your print done, you lift it up by the water, it looks like it's a Terminator coming from the pool of acid or liquids, metal, whatnot. Some pros, it's the highest resolution available. It generally uses UV light, is a plus because you can sort of watch the print come through without worrying that your visible light is going to bother it. And the actual components of the machine itself is relatively inexpensive. The cons, on the other hand, are the limited material choices. Very few manufacturers make materials that is relevant for it. But you know, backyard chemistry has sort of taken up recently, where you can sort of try to mix your own, which is a fun experiment, which I'm looking into. Generally uses UV light, so you have to be sensitive about light poison into your mixture. Everything must be in opaque bottles. If you leave it open just a crack, you could come back to find your entire bottle of material useless, one giant rock. And so you have to be very careful about the light coming into your rooms. It's not as bad as like photography, where you would have to use a dark room, but it's still pretty bad. Yes, and it needs protection from natural light. And Fused Deposition Modeling, FDM, draws on a layer at a time with molten material. It's currently the most popular choice for hobbyists, and it was popularized by the mid-2000s when the key patents expired that allowed people to make their own third-party 3D printers. For the longest time, Stratasys had held the patents, and their standard 20-year rule applies. And then after that, the RepRap project started picking up with the designs they had in mind. And the first design, let's go with it. So it's popular. So you can find the materials in many different places. The materials themselves are relatively inexpensive. A standard unit is a kilogram roll, which regularly can be gotten for $30. And there's a wide selection of printers. Essentially every booth at the maker fairs nowadays have a printer that they're trying to sell. You can find one that will fit your every needs if you know exactly what you're looking for. The cons is you have a limited material choice. That's getting better, but for the most part, you're going to be limited to ABS plastic and PLA plastic. The printing process is relatively slow, and we have reached the bottleneck for how fast we can actually print. There's a few little places we can eke out more, but it's all based on how fast we can get molten plastic flowing, and we're sort of at the peak there. And the quality varies greatly in the printers. As I said, there's a lot of them. You have to choose wisely. Otherwise, you're spending $500 on someone else's trash. Excuse me. Okay, that's not correct. There we go. Now we're on to the RepRap project. RepRap stands for Replicating Rapid Prototyper. It's the 3D printing open source project designed to make a self-replicating robot, meaning that most of the parts they want to use are ones that can be printed on themselves. RepRap has been around since mid-2000, and they started with the Darwin. This is the first design for 3D printers from the RepRap group, or collective. So the base design of the early RepRaps were all based around plastic printed blocks with threaded metal rods. This was a design choice because the threaded metal rods were available in most places in the world, just from a standard construction store. And plastic parts can be shipped quickly and cheaply around the world from other RepRappers. So once there's one in the wild, you can easily pass around the design to everyone else. This design went a little bit overboard with the amount of structural constraints on it. Each of the wall is made up of, looks like 3 or 4 different rods, and it's a little bit over-engineered for what it was intentionally designed to do. Sorry. Early on, the hardware, the electronic components were also very base bone. Modern day 3D printers use Arduinos and other microprocessors to control everything. The early design actually used serial ports to communicate back to a host computer, which, much in the way of the industrial machines at the time, was really overkill for what they needed, and it really added a lot of overhead from the computer standpoint. And it's difficult to align everything correctly because you have so many parts, so many calculations to make for the angles. it was very tedious to put together, which led us to the version 2, which looks familiar because that's the Prusa Mendel. That's the design that I chose for my printer. This one was made by Joseph Prusa. I think I don't know where he's from. But he continued on with the design of the plastic blocks and the steel rods. But the construction of this made it easier to put together. For instance, the only alignment you needed to do was between here, here, and here, and you had a perfect A-frame design. And then once everything else got together, it was perfectly square. Much easier than the original Darwin design. The part counts were also greatly reduced, particularly with the metal parts that were used. The RepRap Foundation or group calls the metal pieces vitamins. I'm talking too fast, aren't I? Okay, I'm getting a bit out of breath. So they reduced the number of vitamins used inside the design to increase the printability of the actual design. This sort of has become the forgotten member of the family for the RepRaps. It was quickly and thank you. It lasted a long time in the field, but not many people were able to actually get them successfully working the way everyone wanted to. And by the time everyone started building them, we had already moved on to the iteration 3. This one was also designed by Prusa Mendel, but it was also designed to be slightly less printable. And for this particular one, they decided for rigidity over, the original design goal of the RepRap project. And essentially everything can be done with a 3D printer and a laser cutter, which, is a fair compromise. The steel rods don't make up the base components of it. Some are still used for the X-plane, the equivalent motion to this one right here. But otherwise, everything's connected to that back plate, which the design files specify that can be anything. The design files have a wooden version, they have a metal version, they have a plastic version, all based on what you have available to you. So it's still trying to get 3D printing everywhere. It's just cutting out the step of being 3D printable, which is a fair compromise, I would say. Some purists don't agree with that. But it is a nice design, and essentially it is the de facto design if you're making a kit to sell to customers. If you're buying a kit nowadays, you're probably going to get some variant of this design. Let's see. Yep, and that backplate is simple. There's even some videos of the original designer, Joseph Prusa, printing it on its side. So, having it up against the wall. And this allows some neat things where once the heated plate cools down, the print can fall off, so it makes it infinitely printable. So you don't have to worry about cleaning off the print and then going on to the next print. This is a cute little design that I enjoyed. Never actually became a real model that people started using, but this is the Tantalus. This was the counter reaction to the previous design, cutting away from the 3D printable aspect of it. This is the most, until very recently, the most 3D printable design. All structural pieces are printed, meaning that only the mechanical pieces, the movement, the belts, the pulleys, only they are bought at the store, and they're all standard off-the-shelf components. Delta robots also gained popularity, and mostly because they have high movement speeds and accuracy. They are able to have a taller build structure, and they look a bit cooler. As another aesthetic note on it. The 3 arms control the X, Y, and Z. It's more of a radial component system, and everything prints through there, through the head at the middle. And they look cool. I don't have much experience with those. The speed that are available that they can move at is a lot faster than they can actually print at. So essentially, if you have Delta frame, you're set for life as long as you keep it calibrated. This is the Samuel. This is another design trying to keep the spirit of the old RepRap project alive. This is designed using all the vitamins, the materials from the Generation 2, the Prussian Mendel, but it's designed to act like an Iteration 3 design. And this is still in development. And this is one that I'm thinking of converting mine into at the moment. It just looks pretty cool. And it's, sort of prevents the old machines from being thrown out with the newer technology. We keep recycling, keep them going through, avoid waste. Okay, so now we're on to material choices. We have very limited selection, but we still have some nice selections. We'll get to the basics first. The first is acrylonite butystyrene, ABS. I tried. For the longest time, when there was an article in the traditional media about 3D printing, they would always start the article saying, ABS, that stuff that Legos are made out of. And so ABS is the stuff that Legos are made of. This is the first material that the RepRap projects tried to get working because it was widely available in a stick form that was distributed for plastic welding, which some manufacturers in China use to put together their injection molded parts. There are some limitations to it. ABS, if not in a heated environment, it will warp in a weird way. So various different parts will bend up or bend down based on how much heat is applied at a given time. And if it doesn't cool down slow enough, it'll become warped, and it doesn't work as well if you don't have a heated bed, which my printer does. And it really truly needs a heated system. So if you lock this into a box and put a little heater in there, that's what you need to print it well. You can print it moderately well. I don't have the heated box, but this is actually printed in ABS. And you can see it came out relatively well. If you want to pass this around, go right ahead. And that's ABS right there. It becomes printable between 200 degrees and 250 degrees. And it requires a bed heat of about 100 degrees. So when you're printing, you're going to try to avoid getting burned. PLA is the more preferred plastic for hobbyists. It's polylactic acid, that's easier to say. It's a bioplastic made out of corn. It's very moisture sensitive, meaning that it can, if it's in a moist room, it will collect water and it will really affect your prints and can lead to clogging of your printer if you leave it moist enough. Most manufacturers ship the actual plastic, this particular plastic, with plastic bags to store it in and little silica packets to keep it dry. It's also very hard. So any post-processing you want to do on it will probably take a little bit more time because of, if you're sanding a hard thing will be a little bit harder. And if it's also brittle because of its hardness. And there's a chance that the plastic could snap while you're trying to print, leading you to try to have to refeed while you're in mid-print, which is a very difficult thing to do without ruining your entire print. It has a lower melting point, which is a good thing. Allows you to have a cooler system, less chance of a burn. But it also has a glass transition temperature that is relatively easy to obtain in a closed-off car in the summer. So there's a chance that if you're printing with this, if you leave a print in your car in the summer, when you come back, it'll just be a puddle on your car seat. I've never experienced this, but other people have. Just something you want to keep an eye out. You have to choose your material for what your project entails, right? Polyvinyl alcohol is another material. This actually dissolves in water. And you might wonder why this would be useful, but when you're printing very detailed models and very intricate models, you're going to have places where there's overhang. And various places you're going to want support for that overhang. Occasionally you just make up waste material that doesn't fully connect but partially connects, so you can easily scrap it off. But if you're looking for a high detailed and you have multiple extruders on your printer, you can use this to print in a support material and have it easily dissolve off in hot water over the course of 24 hours. And PVA is also used for glue, so the waste material, dissolve it, you can glue it, use it to glue books and stuff. Fun little fact there. So here's a demonstration of PVA being dissolved off. You see the gray cube has the white bits in between and dissolving in water, and that's the final print. Once everything's dissolved, it allows you to do some cool stuff. High impact polystyrene is a polystyrene variant that behaves much like ABS. This is a relatively new addition to what people are using in their printers, and it has some neat properties. You could use it as a support material. It's relatively easy to dissolve, and it doesn't use the same solvents as ABS, so you can use it with ABS and get a nice ABS print using that. Otherwise, you can use it as your base material, and just it's a bit environmentally friendlier than ABS, but not much. I'm going to take a little interjection here. These plastics, they produce smells, they produce chemicals. You might want to open a window. ABS itself doesn't actually damage any internal tissues or anything if you're printing in a closed-off area. There has been some reports that you might have a decreased sense of smell if you are in a prolonged period of time with ABS printing, but ABS only becomes cancerous when it goes above 400 degrees Celsius, which your printer should never do. But, just keep that in mind. Otherwise, PLA is the least environmentally unfriendly. That's not the right way to say it, but you get what I mean. Some people say it smells like cookies, and there's no actual negative aspect to it, so that's why most hobbyists choose that one. I'm just a little sucker for ABS. PCL, polycaprolactone, is an interesting material. It's a very low melting point. Like you can melt it in hot water, melting points. You might have seen this online recently where you just put it into a boiling cup of water, it turns invisible, and you loop it all up and you shape it, and it solidifies into some sort of shape. You can use that for 3D printing. It's not widely used for this, but it's a fun little project you can try. You can try using it as a support structure because it's easily meltable without reaching the point that you would melt any other materials. And it's widely available at craft stores under the name Polymorph and other like materials. It's also the base component of Worbla. If anyone's a costume manufacturer, you might have heard the name Worbla before. Worbla is just this and sawdust. And that's fun fact number 2. Okay, PLA composites. So the PLA materials can have particulates suspended in them to create different effects. Common ones are wood, metal, and oh yeah, carbon fiber. I didn't realize that was right there. That's a lot easier. Okay. Wood, the material based on wood picks up some characteristics, like it takes stain really nicely. It does become a bit more like wood in the material choices. It sands easier. It very much looks like wood. You can see a lot of examples online of a material called lay wood, which is the commercial name for it. Metals also pick up metallic elements. They can rust like metals. They can be sanded, and they look relatively shiny. Some people even use rock tumblers to polish up their models, and they all and that also works. Carbon fiber. It's carbon fiber. It's going to be a very black material. It works, but there's other types of carbon you can put into the PLA, and those are the ones that make it really conductive. And you can actually print your own circuits. Recently, there's been a couple big printers who've been trying to push that model. They have printed quads, drones, and had the actual circuitry built into the frame itself. And it's this neat little project. The resistance of the actual material is a bit high, so you wouldn't be able to use it for any high-speed, high-frequency type stuff. But, you know, flashlights and cute little things for kids' crafts, go right ahead. And all these materials, since they have stuff suspended in them, have a high risk of jamming your printer, which leads to a very messy and tedious clean-out process, and potentially could lead you to have to replace the nozzle on your printer. And in particular, the carbon used in the carbon fiber and in the conductive material can actually eat away at the inside of your nozzle. And once you get into calibration of your printer, the nozzle size is really important for making sure you get high quality prints. So once you get to, once it eats away enough, it will ruin your nozzle and you have to replace it. There is a manufacturer making a steel nozzle to prevent that, but that also has a different thermal profile, which would cause your prints to come out a different way altogether. This is a relatively neat one. It's tea glaze. It's a very clear, very light, heavy plastic. It can be used like a fiber optic type effect. You can use it to make light pipes. As you can see here, you can make a very clear bracelet. You can make very clear stuff with this, and it looks pretty amazing. You can also do post-processing on it. So there's some smooth-on products that actually make it even more clear. It's really quite an amazing material. Unfortunately, I haven't had the chance to use it yet, but this is a very cool one to keep an eye out for. And nylon. And of course, nylon is a standard material. It's very flexible, but it has a really high temperature limit. Pictured is a dress worn by someone at Fashion Week last year, or the year before, and it's made entirely out of nylon. The actual design was printed on an SLS printer. It was done through Shapeways. They did it as a promotional thing. But it allows for flexible designs. And there's other flexible materials out there. But this is high durable, flexible design. A lot of people, when printing stuff, they print gears. And this is a good material for that as well, because it doesn't have as much friction, doesn't have as much erosion on the parts as they're moving. Okay, we're at the printing stage. Now that we've chosen the material we want to print with, we want to know, hey, how do we print it? So first things first, you've got to get a model. And that's a whole different talk altogether, how to make a model. But once you have your model, you just have to make sure that your model has no gaps in it, It must be able to hold water, or at least be able to not have any missing polygons. Like if there's a little gap there that's not filled with anything, you have to fill it. And then you can print it. All faces must be pointed outwards. A plane in a computer versus a piece of paper in real life is a plane in the computer only has one side, and that side must be facing outwards. Otherwise, your print will not come out the way you expect it. If your printer is not big enough to print the object, you might need to slice it in half, or quarters, or various different designs. For instance, the helmet is made up of 10 different pieces that were fused together at the end. Then once you have your models, you can slice up your code. Slicing converts your model into G code, which is the toolpath that the head of the printer makes when it's printing. G code is a common format. It's used in all CNC and 3D printers. It is also unique to each machine. It's much like a machine code for a computer. You need to recompile it for the machine you're working on. Otherwise, one machine will print out something completely different from what you expect. Cura and Slicer are very popular options for slicing up your model. Cura is owned by the Ultimaker company, but it is mostly open source. They do have some closed source components, and it's a relatively nice interface. As a demonstration, I have loaded up a model into Cura right here. Nice little jack-o'-lantern for the Halloween. It is that month after all. You can see you have a bunch of different options for choosing the layer height, the shell thickness, how fast you want to print at, how hot you want to print at, what type of support material you want to use. You can choose anything. And with Slicer, you can choose a lot more things too. Slicer provides a lot more options to choose from when you're choosing your print settings. And then once that goes through, you'll get something like this as your toolpath. This is just a slice at one layer. And you see the red shell is the outside shell, and then the green shell is the inside shell. There's only two shells on this print, and inside the yellow area is the infill, and that is just how it fills up the rest of the model. It could be, you can choose how much you want to infill it. That's one of the options back here. Yeah, the fill density setting will allow you to choose which one you want. And so that's Cura. It's a nice design. It comes with the Ultimaker, and the Ultimaker is a nice printer too. Okay, and once you finish your model, once it's off the printer, you can remove support. You can, if you're using ABS, you can use what's called a vapor path to smooth your model. This involves heating up heating up acetone slightly and having your model suspended over it. Warning, acetone is explosive and you're making a cloud of acetone, so you might want to avoid sparks near that. This is something you might want to do outside. Or you could also take the easy route and sand it and file it and fill it. So you can use stuff like Bondo, gesso, other craft type stuff where you can use wood fillers even to build it up and then sand it down to make a nice smooth print. Some people say they prefer the actual layered look of 3D prints, so you can leave it unfinished. It's all up to you, all what you need for your project. If you're going for a stylistic thing, you might want to finish it up a bit. If you're going for a very industrial thing, you might just want to leave it raw. It's all up to you. And advanced techniques, you can even make molds of your prints and cast them. For instance, you can make jewelry molds, and you can melt out the material and have it replaced with metal using what's called a lost wax casting. There's various materials available that you can do that. You can also use aluminum if you have an aluminum forge. You can use a lost PLA casting, which you pour molten aluminum on top of a PLA object that's encased in sand, and the aluminum takes the shape of the PLA model and burns off the excess plastic. Of course, you're working with molten aluminum there. You know all the safety procedures for that, right? But yeah, that's something you can do, and something that people have done, and there's various tutorials online for all these things. And now that's the end of the slideshow, and now it's time for any questions from the audience. I've been talking a lot.
So you said that you're going to convert this guy into, or you're possibly going to convert this guy into
The Wallace design.
your fancy, whatever. Is that going to affect how you actually choose to do your prints, or is that primarily a structural?
It's primarily a structural thing. There's a few things with the Iteration 2 design that I don't particularly like. And there's a lot of things that people were touting as being positives when the design was new. For instance, the A-frame itself. It provides a structure for the Z-axis in this direction only. But it leaves the Z-axis free on this side. So there's a lot of wobble on this actual part of the Z-axis, while it's less so up here. That being said, you never really print that high. You only print down at the bottom most of the time. So the stability there is not the stability you need. And so the A-frame is a bit overkill for what they're trying to do. And in fact, it does make a very inferior print because it is unstable here. The Wallace design has the Z-axis fixed at the bottom, and that should cut down on the wobble at the low end. And also, additionally, the design allows for a higher Z. So I can print taller objects as well. Because right now I'm limited to about 13 centimeters if I'm lucky. Yep.
Yeah, so the designs that you'd shown, you said you were going to convert this one into a kind of follow-up to the previous question. How many of those designs can be converted like amongst themselves? Is conversion of one model or one printer to another printer common?
It's not really that common. A lot of the vitamins can be reused from the I2 to the I3, but they made a very big change to the Y-axis, the build plate. They made it so that it requires a slightly thicker rod. For stability reasons, it's a smart design choice, but it also means rebuying all your rods. So that's one reason why I would avoid that. I would have gone with a completely separate kit if I was going to go to I3. Now, the Darwin itself, actually, most of the rods should have been reused for the I2. So it is relatively common that you would reuse parts between them. You won't use all of the parts. The Wallace is unique with that. We'll use all the parts.
I came a bit late, so I'm sorry if you already said this, but did you print the reprintable parts for your printer?
No, I had someone else print it forward for myself. And I keep meaning I'm printing my own parts in case one of them breaks, but I always forget, so.
How long did the helmet take? I know it takes a while to print.
That one, I printed that over the course of a week, printing 24 hours a day, essentially. Essentially I wake up in the morning, I start a new print, clean off the old print. I would come home from work, start a new print, clean off the old print. Before I go to bed at night, I start a new print and clean off the old print. I was working, and one thing, if you're using a 3D printer for a long enough time, you get that buzz stuck in your head. Because if you ever heard a stepper motor chime, it makes a very distinct buzz, the zzz, 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 and you sort of miss it when it's gone. It's very Stockholm syndrome. That's the word I'm looking for. Okay, I have a question in the back from my sister, actually.
So my question, I'm really interested in the applications of 3D printing to the medical realm of things. And I've seen a lot of interesting designs with prosthetics and orthopedics and that sort of thing. What style of printing would you recommend for that? Or is that something that you can kind of play around with as a hobbyist, but just change the field density settings?
That's actually something, the picture up there is one of the girls who received a prosthetic hand from the eNable project. And that is actually all done with the Fused Deposition Modeling printers. The strength of a model itself is dependent on how much of your infill you've made that point. And so it's just a matter of making sure you have a high enough infill. Something around 70% is always as strong, is almost as strong as 100. It's close enough. And yeah, FDM is the right kind of material to do that because it's cheap and it's available, and almost anyone can make a 3D printer even without access to kits and stuff like that. I have a picture of someone using a couple different CD drives and a hot glue gun, and it doesn't look pretty, but it's successful. Okay. You and back. You already had one.
I was just wondering, you said there's a lot of materials that dissolve in whatever particular fluid. Are any of those materials reclaimable after they've dissolved?
Well, that's a good question. Well, ABS can be dissolved in acetone, and you can partially reclaim it. You might notice the light areas on the helmet. It's actually made actually the helmet itself is actually glued together using a paste of ABS inside acetone, and then it just, once the acetone is evaporated out of it, it became a nice solid object. But for reuse, there's a lot of different chemical processes in there that once you reclaim it, they're sort of gone. You had a question first?
Just a quick follow-up to the prosthetics. You had mentioned the other two types of printing. I forget their names, but the other two had, and you had noted them as having higher resolution.
Yep.
I'm just kind of curious as to what kind of factor that was playing into something like prosthetics where naively with high resolution is a good thing.
Yep. Well,
I don't know if that is the case, because obviously there's a number of factors.
for some people with prosthetics, you're looking for matching your human hand, matching whatever you had before, or matching what was lost. And high resolution is ideal there. You want to print in, say, some sort of stretchy plastic. You would probably use an SLS process to make a skin-like material that matches. But these projects in particular are designed for people who never had a prosthetic hand, people who can't even afford one. There's a lot of people out there who can't afford one. And ideally, they would have the matching hand, but this is giving them a step beyond what they previously had access to. So yes, that is a key aspect. Okay.
I was going to do a follow-up to the reclaiming of the material. So I was wondering, like, if say you printed something and there was something wrong with how it was printed, could that be more or less melted back down and reused?
Yes, with wasted prints like that, you can actually melt down that plastic and reclaim it. The machine to melt it down costs as much as a low-end printer itself, and you can't recycle all of it. You have to mix it in with some fresh material just to keep it somewhat fresh. If you understand recycling processes, that's how they all do it. And so yes, I have a box waiting for the day in which I might have one of those machines. So. Hey, and
the finishing process, for example, I personally think that the way it comes out is very cool with the lines. There is smoothing, but is there other materials that you can put on top, sort of like almost like grouting, so it's to smooth, that you can place on top of the surface, and it would fill in.
Yep, there are a couple materials. There are some filling primers which you can use that would try to get most of the stuff in. They're not as good as you would hope. There's also a material from Smooth-On, the people who make resins and silicone and all that stuff. They have a material called X3D, which does exactly that. You mix it up in small amounts and you just brush it on, and it just takes the surface and it just smooths it completely out, all without using an acetone bath.
And about painting.
And once you get on that, you just need to scuff it up a bit so it can take the paint properly, and then prime it, and then you should be able to paint it properly.
Now the paint would also have an effect.
The paint would also have somewhat of an effect, yeah, depending on how thick the paint is and whatnot.
What kind of paints would you use?
I actually have not had that much experience with the paint aspect yet. That helmet in back there was going to be the first one I was actually going to finish completely and paint it up.
Right.
And right now I'm still stuck on the sanding step trying to figure out how best to sand it. But standard model paint should work. They come in small supplies. Also, Krylon Fusion, their plastic model, they also should work properly too.
Thank you.
No problem. Okay.
I guess also I was thinking, what are your thoughts on, because I've seen in a video online, there was a printer that sort of just lifted the plate out of the liquid and it created the model as it was lifting out.
Yes, that's a variation of the the stereolithography that I was talking about earlier, and I think those are pretty cool.
Yeah.
Yeah, I've made that really well clear. I'm in the middle of making / putting together one that should act similar to that. It's using a process called CLIP, which is I don't remember what the acronym stands for, but essentially it's a LCD display underneath the bed, and that would harden the material as it's lifting up. This is a very experimental thing, so it's going to fail completely, but it's pretty cool. And you know, that act of lifting out of the liquid is the coolest aspect ever. When I was a wee person, I saw it on I think Mr. Rogers, and they were demonstrating that, and I saw that. I was like, that's so cool. And that is one of the earlier memories I can remember of television. So.
Casting a really wide net, how far or how much maybe? What does it take at this point to turn this into something where you could actually have like a shop where these just ran and printed objects of general interest?
That's a question I've been asking myself a lot lately. And I honestly, the business model seems like it requires a lot more interest from people. Just a place where you can make whatever you want. Seems like a cool idea and process, but you're a lot better. Well, there is actually a website that allows you to make your money back, let's say, from a 3D printer. It's sort of like an Uber program where you rent time on your printer. Someone says, "Hey, I want this model." You're just like, "I'm in that area. I'll print that for you," and then it connects people with ideas and whatnot. And it doesn't seem that feasible so far, but I imagine once it starts building up with idea of people wanting to do stuff, it could actually be self-sustaining.
I know that like. Oh, sorry.
He had his phrase like 3 times now.
Oh, sorry. I missed a little bit as well, so maybe you did answer this. Have you ever tried actually building your own model from scratch, like building your own design?
Oh, yes, tons of times. Well, of course, I've designed a few parts on my printer itself. You see these little stands for the heated bed. They're all my design, but you know, it's a simple little wedge type design, so it's not that big of a deal. But yeah, I'm in the process of converting a few models to be 3D printable. Those are not my own design, and I'm also I do make my own designs. I should have brought a few more with me, but I don't have them with me. Well, my new printer is all made from designs that I printed and made myself. This is all someone else's designs. But yeah, it's simple. You just install certain software. Autodesk makes their 123D make. It's very simple to use. I also use OpenSCAD, which is a programming-based 3D modeling design tool. And Blender, of course, is the go-to open source 3D modeling software. And I do have a student license to the bigger tools that I probably should stop using.
You have to give a good tutorial on Blender because it's just terrifying.
It is terrifying.
Open it, you go like, I don't have a year to spend.
Yeah, essentially Blender is a lot of hotkeys that made sense at one point, but they've since remapped them so many times that they no longer make sense. Blender Blender 2.6 is actually, you can do a lot of things with just a mouse, so it's very easy to walk through. Blender 2.4 was the worst design ever, but it was better than most 3D modeling software, right?
Okay, is this
It's overwhelming. There used to be a wiki book called How to Noob to Pro Blender 3D Beginners. And that was the title of the book. I don't know if that's still good or if it's been updated to the newest version. But I'll post in the Hackerspace if I find a good resource. I know you're with the Hackerspace group, so I'll post in that group with a tutorial.
Oh, we posted to Photoshop.
Yeah. Say the Protoshed, yeah.
Yeah. Do you find the biggest problem, and this is what we're finding in terms of, we can do it as amateurs, but in terms of industrial process, the biggest impediment right now is speed.
Yeah.
And it takes so long compared to, let's say, milling.
Yeah, and as I mentioned before, that's just the limits of pushing hot plastic out through a tiny little hole. You sort of have to deal with those sort of speeds. You want finer detail, you're going to go slower. They're all budgets you have to make in your design. That's why a lot of people shouldn't be using 3D printing as their base manufacturing model when they're making products. I know a lot of companies try to start off businesses saying, hey, we're going to 3D print everything. And they're making like 50 different pens. And like, no, you're making the same object 50 times. There's better ways to do that than 3D printing. And that's when you get away from the prototype and onto different objects like casting, or even just milling the pens might be faster than printing them. Pen being the example I would pull out of thin air, but you get it, right? Yeah, so 3D printing isn't the ideal situation for everything, but it's great for prototypes and it's great for one-off pieces. Even if you're making up to like 20, you might still be able to make a, but it is a very slow process. Okay, purple sweater.
So I'm interested because, I mean, it doesn't seem like very many complicated parts and pieces and rods. So has there been much work with regards to using it in low resource settings? I know, like you said, manufacturing vast quantities of stuff is probably not the best role for it.
Yeah, there have been some aid efforts that have been assisted by 3D printing. You might be familiar with, I know this person in particular, but you might be familiar with that stethoscope project where the doctor printed their own stethoscope and was able to use it in a war-torn, was it war-torn or was it just a low-income area? Yeah, it was a low-income area, and he printed his own stethoscope, and he was able to circumvent border custom controls and able to provide medical care to, and that sort of stuff is great for this. Like, the materials are available almost anywhere. Even the plastic bits don't need to be plastic. The rep wrap started before the rep wrap was made, right? There was always the rep strap before it, and that's the name they call it. The rep strap is a design of a printer that's using wooden parts that have been milled, even just drilled holes in wood. It's like you can make your own printer without any of the plastic bits, as long as you have the metal rods, which are a commodity item. You can find them certain places. Yep.
Can I ask, are there any materials that are safe to use with food or utensils and plates?
That's a good question. No. Short answer, long answer is there are materials that claim to be safe with food. There's antimicrobial materials. They have antimicrobial elements to it. There's also materials that have been FDA approved, like the PCL, the polycyclone lactulone. That one is actually medical safe. You can use that material. They use that material to make pacemakers and stuff. It goes inside the body. It's safe to use medically. But the key factors for prints are once it goes through that nozzle, it's no longer safe to eat from. That nozzle was made in some warehouse in China. There's probably lead in there. There's probably other chemicals in there. Even if you had a safe nozzle, once you get the print itself, it has all these little ridges for food and organic particles to get into, and that is difficult to clean or impossible to clean. So your print will not be food safe. You can put that smooth-on material I was mentioning earlier, that could potentially keep stuff out of the grooves, but still it's not something that I would personally risk. Yes, my other sister.
My question is, I know ABS is used when it comes to plumbing and that kind of thing, so obviously it's a durable product.
Yep.
But now my question is, how durable are the other plastics?
Okay.
I know plastic itself is a durable, but if I can't break it, I will break it. So I'd like to know what would be the most.
Okay, so for you personally, PLA would not be for you, because it is hard. It's not going to do much, but it's not very. It's brittle though. You can crack it. You can break it. You can bend it. It's not that strong in the grand scheme of things. ABS is a good all-round. Nylon is the best, as I was mentioning before. It's very strong. It's very resilient. The downside of that is that you have to print at a really high setting, which most printers, especially off-the-shelf ones, are not compatible with. But otherwise, ABS, you know ABS, and the other ones are dissolvable and meltable, and they're not going to make it. Good question. And another one in back.
Yeah, I just wondered if you've ever used your printer to replace a part with something that, a commercial product or something. Because I know I've had times when I've broken something or lost a piece of something, and it would have been nice to have a printer.
Yeah, you know the little flaps on the back of the keyboards? Yeah, I've done a couple of those. I think I tried to print a replacement gear for my hand mixer when it broke last year. Didn't last too long because it's ABS, it's going to rip apart anyway. But it is something that I have tried there. And yeah, the first time that I used my printer to make something that didn't directly affect the printer itself, like the first few prints were all about making the printer better. And then the next printer, like, I just made something that was useful. That wasn't for the printer. It's not self-feeding now. Yeah. So yeah, it's a very neat. You just simple. You model up what you were working on, and you print it off, and you have it done within a day, as opposed to trying to find a part online or just replace the entire keyboard. Or yeah, working in a low setting, which is just not right. Okay.
All right, folks.
Oh.
Thank you to Dave.
You can ask me later.
Give him a round of applause.